Get a big nose.
All right. They just throw this as a unit. They just throw everything in here, solving other types of equations. We've already done factoring, but then they're kind of adding another layer to that one. Fractional equations, which means rational equations, anything where you have a fraction in it. And we're going to look at one of those, and then radicals. We're going to look at those. We don't really get into the fourth one there, the ones that are quadratic in form. So now, this is a rational or a fractional equation. If I got something where I'm going to have some form of a variable in a denominator. So we're going to solve x times x plus 1, x over x plus 1, plus x plus 1 over x plus 2 equals 1. Now, when we get into these, we end up getting into scenarios where you could possibly get some answers that we need to discard. We're going to go over it. We are never allowed to divide by 0. So what two answers can we not get, or if we do get, we can't use? Cannot use -1 or -2. So x cannot equal -1 or -2. Okay, so if we would happen mathematically get those answers, when you go back to check it, you gotta throw it out. Don't leave it as a list, or don't leave it as one of your answers. All right, we want to eliminate the fractions. So you need to multiply by the common denominator. Typically, the least common denominator is the best thing. When you have an expression, you cannot take a piece of the expression. You have to take the whole expression. So I'm going to have to multiply everything by x plus 1 and x plus 2. So hopefully you remember that. So I'm just going to rewrite this down here, give myself a little bit more room. X times x plus 1 plus x plus 1 over x plus 2 equals 1. Now I'm going to multiply each piece by x plus 1 times x plus 2, including that 1. Okay, sometimes people think, well, there's no fraction, I don't need to multiply. It doesn't matter, because remember, the rules for equations, if I do something to one side, I got to do the same thing to the other side. If I do something to one term, I got to do the same thing to all terms. So as long as I multiply everything, it keeps it equivalent. All right, what happens on that first one when I multiply x plus 1 times? What happens there? Do you understand what's going on? I guess in that terms. Brooklyn, do you know what's going to happen there?
The x plus 1s are canceled.
Good, that's the whole point. It will eliminate the fraction. The x plus 1s will cancel. And you're going to be left with this x times that x plus 2. So in the second case, Colton, what's going to happen?
The x plus 2 is going to cancel.
X plus 2s are going to cancel. Good. And I'm going to be left with x plus x plus 1 times x plus 1. Nothing cancels in the last one, but it's just a 1 there. And so if there was another number like a 7, you'd have to multiply that 7 by the x plus 1, x plus 2, but the 1's just there. And so this is just going to be 1 times x plus 1 times x plus 2. Well, since that 1 really doesn't affect anything, okay, I'm just going to get rid of it. That's not going to hurt anything. All right, now you got to distribute. You got to foil. You got to foil. Nothing you can do to get around that. So let's distribute. Let's foil. Let's foil. I get x squared plus 2x. Plus, all right, this is going to give me x squared. I'm going to go ahead and just FOIL it all out. Plus x plus 1 equals x squared plus 2x plus x plus 2. All right, on each side, I'm going to combine like terms. Okay, anything with an x squared, anything with an x, any constants. So what do I get over here? I get 2x squared. 2x, 3x, 4x. Looks like I get plus 4x plus 1 equals x squared plus 3x plus 2. At this point, you don't know whether you're going to get a linear equation. Well, depending. like when you start, you don't know whether you're gonna get a linear equation, which means there's no x squares, or if it's gonna be quadratic in nature. As you take a look at this, is that gonna end up having an x squared in it? It's got to. Okay, you're never gonna get rid of it. You would get rid of it if you had like 2x squared here and 2x squared here, they would add up to 0. It would be gone. It'd be a little bit nicer. So if I'm going to get an x squared, I'm going to set it equal to 0 because I'm either going to factor it or I'm going to use the quadratic equation. So I would move everything on the right side over to the left. Okay, and I would do that and set it equal to 0 and see where I'm at there. So I'm just even going to show it minus x squared. I'm going to subtract x squared here. Well, minus 3x. Well, minus 3x here. I'm going to subtract 2. And let's see, what do I end up with? I end up with x squared plus x. Whoops, make that next. Plus x minus 1 equals 0. All right, we've done all that. We're not done yet. What are my options? Try to factor it. All right, see what factors. Okay, done factoring. So what do we do now, Hammer?
Complete the square.
Oh, you can complete the square. You can go right ahead. Okay, I'm going to do quadratic equation. And like I said, if he wants to, he can. Absolutely fine. I can. Sometimes it's quicker. I'm going to use quadratic equation. Sorry, you got to do it. There's no other way. We got to solve it. So we're trying to figure out the answers that'll work for this equation here. And so I get we got x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Opposite of b, b's 1, so it's going to be negative 1 plus or minus, what do I get there? 1 squared minus 4 times 1 times negative 1 all over 2 times 1, which is 2. Yep. What do I end up with in the radical? Plus or minus 5, right? Okay, square root of 5. That's my discriminant. All right, negative 1 plus or minus square root of 5 equals 2. All right, good luck checking that one. Okay, that could be just a whole test in itself, solving that equation and checking it. All right, right there. So, but it's not an answer we have to throw out because we said we couldn't equal negative 1 or negative 2. Those clearly are not negative 1 or negative 2 for that one. All right, there's our answer. So you got to be able to get rid of all your fractions. Then you got to evaluate, all right, what kind of equation do I got? And then you got to solve it. All right, so that's the first one. So this is a rational equation. We're going to do radicals. Principle of powers is good to get. You don't need to get all this in blue. And this is a useful tool. The principle of power says if two things are equal, if you take them to the same power, you square both sides, you cube both sides, you take them to the fourth power, then they're still going to be equal. But there's a big but. No, not really a big but. That's not proper terminology. There's a big if. When solving equations using the principle of powers, you must always check for extraneous solutions. Extraneous solutions are solutions that work for the modified equations, but not for the original. Okay, it doesn't mean you made a mistake. It doesn't mean you made a mistake. You did everything right. It just means it doesn't work for the original. A real simple case. Let me show you this here. And you know what? You would never do this, but it just shows what's happening. 2x equals 6. What does x have to equal? 3. Okay, we all know that, right? If you square both sides, it still has to be equal. But if I square both sides, I get 4x squared equals 36. If I divide by 4, I get x squared equals 9. And if I take the square root, what is for x squared equals 9? What can x equal? 3 or negative 3. So it equals 3 or negative 3. Well, negative 3 still works up here because 2 times negative 3 is negative 6, but when you square it, you get 36. But clearly negative 3 doesn't work over here. All right, so this is a case where I squared both sides. It adds in an extra solution that works here but doesn't work for the original one. So anytime you square both sides, cube both sides, you got to test all answers to see if they work. Okay? Don't assume that they don't. All right, let's take a look at this with radicals. You'll do some with just one radical, which aren't as bad. We're going to take a look at the one with 2 radicals. I think it's going to be helpful to go through the explanation. Okay. If you come up with an equation with 2 radicals, you need to, before you to get rid of a radical, you square both sides. Before you do any of that, you want to at least isolate one of the radicals. Get it by itself. Okay, otherwise it won't work. Okay, so we need to isolate one of the radicals. I'm just going to isolate the square root of x plus 2. I'm going to subtract square root of 3x plus 4. I'm going to subtract square root of 3x plus 4. And then I get square root of x plus 2 equals 2 minus square root of 3x plus 4. All right, here's what you got to watch. I'm going to do it over here because I'm recording, but you don't necessarily need to get this down. You got to watch. If you have A plus B equals C, okay, you cannot just square the individual pieces. You cannot say A squared plus B squared equals C squared. That will not be true. Okay, that will not be true. Even though you think it is, it's not. A real simple case. 2 plus 4 equals 6, right? You agree with that? Square each one of those. What's 2 squared plus 4 squared? Does that equal 6 squared? 2 squared is 4. 4 squared is 16. What's 4 plus 16? 20. And what's 6 squared? 36. So 20 does not equal 36. What does that have to do with this? It means you cannot square the individual pieces. When you square both sides, you got to put an umbrella around each side. Then it'll work. What I mean by that is I can now take this, I take the whole thing, square it, and I got to take this whole piece and square it. You don't just square individual pieces. That doesn't work. On the left, when you square the radical, that just leaves us x plus 2. All right. Over here, you got to FOIL that. You got to FOIL that. Now we'll be okay. All right. Thank you. Okay. Now we got to FOIL that on the other side. I'm going to take my time here. 2 minus square root of 3x. I'm just going to write it out for the first times. 2 minus square root of 3x plus 4. And now that just stays the same. Equals. All right, when I FOIL, I get 4. And I get 2 times that whole radical. The only thing you can do is write minus 2 square root of 3x plus 4. Remember, you cannot multiply anything we talk about outside the radical by anything inside the radical. So that 2 just goes on the outside. Same thing for the second or the third piece here. That's going to be minus 2 square root of 3x plus 4. And then negative times a negative is a positive, and when the radical times a radical will basically get rid of the radical, and you'll be left with 3x plus 4. I'm going to simplify anything I can on that right-hand side. X plus 2, there's nothing I can do here. And so I get, I'm going to make this 3x plus 8, and then this is going to be minus 4 square root of 3x plus 4. All right, we start out with two radicals, but we still have what? We still got one radical. That helped us eliminate one. So we're going to have to do the same thing. We got to isolate the radical again. Okay, we got to isolate the radical again, which means I'm going to subtract 3x. I'm going to subtract 8. And now that gives me minus 2x minus 6 equals negative 4 square root of 3x plus 4. There's a lot going on in this one problem. All right, you do have two options. When I said isolate the radical, you might say, all right, let's get rid of that negative 4. This is a step you can or cannot do. You don't have to. Let me show you a second. Don't write this down. Here's what I'm going to evaluate right here. You can divide by negative 4, but you got to divide each of these by negative 4. Now, here's going to make my decision. If I divide this, will it give me a whole number or will it give me a fraction? Then I'm not going to divide by negative 4. If it would give me a whole number, say that was a 2, and I would get x minus 3, then things are nice. I don't want to deal with all the fractions, so I'm going to leave it over there. If you divide and it gives you whole numbers, I would do it. Well, what do we do then? We have to square both sides again. You got to get rid of the radical. When I square this side, you got to put an umbrella around it. You got to put parentheses around the whole thing. Square. You can't square individual pieces. Negative 4 square root of 3x plus 4. On the left, you got a FOIL. Negative 2x minus 6 times negative 2x minus 6. And equals. All right, now this is not a binomial. You do not have a plus or minus in between the 4 and the square root. It's not a binomial. So, it is, you can think about it as writing it twice, but you're not going to FOIL. You're just going to take negative 4 times negative 4, which is 16, and then it's multiplying square root of 3x plus 4 times square root of 3x plus 4, which is just 3x plus 4. All right, so FOIL, distribute, and then stop and look at everything. FOIL and distribute, and I'll catch up with you in a second. All right, negative 2x times negative 2x is 4x squared. That's going to give me plus 12x. And I'm going to get another plus 12x. I'm going to get plus 36. And I'm going to get 48x plus 64. Should be an x there. Okay, that gives me 4x squared plus 24x plus 36 equals 48x plus 64. All right, am I going to end up with an x squared? Yep. So I'm going to move those two things on the right to the left. I'm going to subtract 48x. I'm going to subtract 64 minus 48x minus 64 minus 48x minus 64. All right, what do I get here? I get 4x squared minus 24x minus 46, 56, 28 minus 28 equals 0. All right, we're getting closer. We're getting closer. What are my options? Whoa. Ty, what are my options? What are your options?
I was gonna take out a 4.
All right, we can take out a 4. You got GCF. All right, that makes life easier. Good. Take out a 4. X squared minus 6x minus 7 equals 0. Now, you either factor or use a quadratic formula. I will tell you that this factors into x minus 7 times x plus 1. So my answer will now be x equals 7 and x equals negative 1. All right. What we did on that last slide, we now got to check. We went through this. We squared this twice. You have got to check the answers back in the original and see if they work. So one of you take 7, plug it in the top. You can just do it manually or you can write it down. And one of you take negative 1 and plug it in the top and tell me whether one works, both work, or neither work. So you got to substitute it in. Okay, so do that now. So check. 4. Extraneous solutions. By plugging in 7, by plugging in negative 1. Okay, and seeing whether they work. Brian, which one did you check?
Both of them.
Did they both work?
No.
Which one didn't?
7.
7 didn't work. All right. 7 plus 2 is 9. Square root of 9 is, this is always the principal square root. It's written like that. Square root of 9 is 3. Plus 3 times 7 is 21 plus 4 is 25. Square root of that is 5. Well, 3 plus 5 is not 2. So that one doesn't work. Does negative 1 work? Yeah, because what do you get? I get a 1 here and I get a 1 there. 1 plus 1 is 2. So we didn't do anything wrong, but 7 does not work. So you got to throw that out and you got to make sure you're clear in your answer to me. You got to tell me x equals negative 1. You cannot leave 7 as one of your solutions. It is not a solution. All right. Whew. There's a lot in that one problem. Okay, a lot in that one problem. All right, here's what you're going to do. We only went through 2 problems. These examples 1 and 2 are from the examples in the book. Okay? So 9 and 15, you're going to need examples 1 and 2 to help you with it. Okay, now maybe you can get it looking at it, but if not, you go to examples 1 and 2. 21 and 25 are like the first one we did, but they're also examples 3 and 4 in the book. 43, 47, and then 55 is like this last one. 88, that's just a special one. Okay. But you should be able to generate. All right, you've got the rest of the period. Get as far as you can. If you get stuck, you are allowed to ask me. That is acceptable. But here we're trying to get you to the point where you can use your book a little bit. You understand what it contains, and then kind of reading a math book. Because I tell you what, if you can't help yourself in college, life is a lot harder. Okay, you've got to be self-sufficient. You got to be able to come up with things figure things out when it doesn't make sense, even though you were in class, and even though you took notes, and even though you paid attention. Everything won't always flow perfect. If you want to work with somebody you're not sitting with, that's fine. Help each other out.